well, the next step is to add audio in. A lot of these things can be seen as little puzzles. So if you like to puzzle, then discovering TouchDesigner is perfect. Because like you get a little problem and you can, or one thing with these, what I find amazing about computers is that you can do whatever you like, they don't break. You have to do quite a bit in TouchDesigner to break your computer. I'm not sure if that's really possible, but you are absolutely free to mess all systems up and then just click close and start again. So as long as you, it's a very playful environment because you discover what you want to do. Yeah, it's a discovery process, and eventually it just becomes well, second nature. I mean, the other thing that I like, and that's a really quick detour. Currently, you see it all on alpha on the checkerboard. Now, personally, I think I know when I work with alpha. I think sometimes I might be mistaken. So what I would do is right-click on the output of the render 1 node, and the upgrade dialog and the top family comes up, and you can choose a transform. Choose a transform top. And the transform top has this option to add in a background color. So 2 parameters that you need to set. A, the background color is currently black with no alpha. I want a black background, so at least I need to set the alpha to 1. Secondly, you have to use the toggle comp over background color. What you get is a black background. And now I take off the display flag from my render 1 and put it onto the transform. And I have a black background. I see a little bit more right away. So for audio, we need an audio file. That is something that Greg showed us how to do. So I'm gonna somewhere over here in the beginning, because I have a feeling that I probably will have to adjust the particle system fairly early on with the audio. So I will hit tab to bring up the upgrade dialog and audio file in. Audio is a waveform, so we're looking at chop channels, channel operators. So click on chops and bring in the audio file in chop. Yeah, audio file in, and you have a default audio file playing. Just to create chaos in this room, I would ask for you to right-click on the output of the audio file in and choose an audio device out. And as soon as it's up, I would recommend in the parameters to turn the active flag off. But at least now you know what you're doing to what the signal is. So you basically, that's the way how you can listen, how you can output audio from Touch, is any kind of audio capable channel data into an audio device out, and you can listen to it. Which works, by the way, with all kinds of data. Like you can output images if you like. Convert a top into chops. Now you have to adjust the sample rate of it, because I mean, if you look at audio, middle mouse click on audio, you see that you need a sample rate of about 44,100 samples per second. But you already did all the steps to do this, like you converted an image to channel data. That was one of the first things Ben showed you. And then a little bit more, and you could output an image. Anyhow, so good, we have audio. Now, in the original file, if I play this, it looks very much like these particles are shooting out with the waveform. And that means, for me, that probably the audio, since I already figured out that I can control how these particles are being, how these particles come out of the circle. So, like even me wiggling this, I can create certain, me wiggling the multiply on the map, I can already kind of create something like an audio waveform, not really, but anyhow, this is probably where we want to multiply in the audio wave. Like if we multiply these channels, the TX, TY, with the audio channels, then probably my normals will deform in a way that looks like an audio waveform, and with my normals deforming in that way, my particles will shoot out this way. So there's two problems here. A, my audio waveform is 44,100 samples per second, while my SOP2 is my regular 60 samples per second. So I should somehow probably bring that closer together. Greg showed the resample job. So middle mouse click on the audio file in, middle mouse click to create a new branch, right? Because we don't want to, for the audio out, we still want to have the full sample rate. We need a new branch. So middle mouse click on the audio file in, on the output of the audio file in, choose a resample job, this one here. And the first thing we need to do, we need to turn off time slicing. That's a recipe, just remember. On the comment page of the resample job, turn off time slice. Now, we want the channel to be, we probably want every sample, we want to have 735 samples of the information at 60 hertz, at 60 frames per second, samples per second. Now, that would mean, but my time range here is only 1 frame. I have 735 samples in 1 frame, and I need 735 samples in 735 frames. So I have to, the method that I have to choose in the resample job is not new rate, same time range, because it would still just leave me with this really short time. But I actually, I could just set new index range too, right? New rate, new interval, that's what I need. The last option here, because my new rate will be 60 frames per second, 60 hertz, and my new interval shall be, if I look at samples, 0 to 735, because I need 735 samples.
What happens if you don't resample?
Potentially all hell breaks loose. If I put a merge here, for example, now I'm dealing with, so this sub here currently has 40 samples at 60 samples per second. This comes in with 730 samples. The merge job is going to try to align these two. Like the audio is on the timeline, the audio is somewhere here, and my sub is very steady here because it's not animated and nothing, it's just sitting there for the first frame, 1, 2 frame something. So now the merge is going to try to align these two. Oh, it actually did a pretty good job, but it's not nice anyway. As I said, it's setting it to the sample rate 60. We're back at the resample job, and now my new interval I want to set, and the default here is relative to start end. Relative to start end means it's gonna somehow adjust the interval of the input relative to its current start end position. And if you look at my start end, it's like racing along. It's never constant, never stays static. But this here is totally static, and that's what I potentially want. So what I will do is my unit values should be absolute, and my start end, I don't know, I really don't want to deal with seconds here because I would have to do like conversions and stuff, but I know that I want 735 samples. So start end have these extra menus back here where you click on it, it shows you samples, frames, seconds, or fractions.
So you take frames?
Samples. And if I want 735 samples, that would be start at 0 and end at 734. That's because it's 0-based. So 0 is your first sample. If you need 735 samples, you end up with your range is 0 to 734 instead of 1 to 735. But it makes still, if I look at it, it tells me that it's actually 735 samples long. Well, we're gonna use it in the math because, as I said earlier, I want to multiply all these channel values with the normals, or with the channels that are going to the normals. So the math currently has a multiply, but we did this earlier here. The math is able to combine channels, like we divided two channels, but underneath it says combine chops. So that sounds potentially interesting. So if I want to combine the sub2 one and the resample one, it's going to plug the resample in here. And on combine chops, select multiply.
Sounds very creative.
The math has a, so it's the math one in the beginning, right? The first math we put down, and it has a combine chops parameter where we combine two branches into one by multiplying the channels.
Yeah.
One of the issues we are having is that we have a circle with 40 points. So this channel has only 40 samples, and the resample, though, we set to have 735 samples. And what you see is happening is that it looks almost like there is something more multiplication going on here in the beginning, in the first 40 samples, and then it's just audio waveform. So what we actually have to do is increase the number of points on the circle to match the number of samples that come from the audio waveform. Now, before doing that, we should perhaps think about taking the life expectancy of the particles down a bit. So for me, the first thing to do would be go to the particle sub, change life expectancy to 1.
Yes.
So it's the particle sub parameters on the particles. I set the life expect to 1. And now back on the circle sub, the circle has divisions, and currently it's set to 40, which it basically creates 40 points. Now I said what's coming in is 735 samples long, so I want to match that. So I'm just going to type in divisions 735. No, you have to match it so that every particle. So if I take my sound wave like that, and I wrap it around the particles, the circle, then I want every sample of the audio connected to one point of the circle. So there's two things that are happening here, and I'm not quite satisfied with what's actually happening. The one thing is that currently my particles are like it's not creating enough particles per frame to create my effect. My circle is 735 points in total, and I'm creating 100 particles per frame. What happens if I want to create 735 particles? That's already better, but it's still not enough. It's creating 735 particles per second, but I want to create 735 particles per frame. That means, so now everybody not type this in yet, or save. Maybe save. Save.
Will be so many particles that you crash.
Yeah, if not everybody follows me here, then we'll crash. So 735 times the frame rate, which would be 735 times 60, is a quite high number. And the amount of particles created might overpower the CPU. So how I can counteract this is by removing the life expectancy, like moving it way down. So let's say, I actually wrote the number down. Let's say 0.1. So if everybody has life expectancy at 0.1, now I'm going to say birth should be 735 times 60 because I have no clue what that number is. Oh, look at that. It's 44,100. What a coincidence. So I'm getting somewhere, but this is way not where I want to be. Like this circle is weirdly like a egg going. I don't know how to call this. So looking at this and comparing it.
How to compare?
Comparing it with this output here, there's something weird with this here. Like there's something just not matching up. And one of the things is that what I didn't look at, I have these two channels here from audio left right, but I'm just multiplying them with the TX, TY, TZ here. So what the math is going to do, it's going to multiply TX with channel 1 with my left channel and TY with channel 2, my right channel. But that's not what I want. I want the whole thing, the left side to be affected by the left channel and the right side to be affected by the right channel. Yet they need to be applied equally to TX and TY. Like, otherwise you don't get a circle. So one easy way to do this, we basically have to merge these two channels, but we need to take the second channel and put it at the end of the first channel. And there is a job for that. So after the resample, right-click on the output of the resample job, and there is a job called shuffle. And the shuffle job comes with a method parameter. And one of them is sequence all channels. So sequence all channels, it takes literally all the channels in your job and just attaches them to each other. So what we'll end up with is, here we have two channels with 735 samples each. So now by sequencing all channels with the shuffle job, we will end up with one channel with 1,470 samples. And it's already much better here. Like I'm already getting a better result. But previously I set my point count on the circle to 735. I should double that because I just sequenced these two channels. So, damn it. There.
Could you just click on the shift one? I lost my shift one.
Oh, it's not really important though, the shift one. The important one is the shuffle.
Yeah.
The shuffle after the resample. And set the shuffle to sequence all channels. And right after, change the divisions of the circle sub to 1,470 because that's how many samples are coming in from the left and the right channel combined.
Yeah, you can always confirm the number of samples in your chops with the middle mouse button, and you want to match that with the number of points in your circle.
1,470, and I set it to 1,470 already.
Yeah.
And of course, previously we had we changed our birth rate to be 735 particles per frame, and we want to change that to 1,470 times 60 as well. I need like a. Isn't there like a magnifying glass? Oh. Sure. Yeah, you can save it now. If we'll skip one small step, and
It's getting too heavy.
right. If it's too heavy, you can always turn down the on the particles the life expect. Like make this 0.05.
I think
But it's possible to have less
I must
particles.
actually here. with the
I think I'm struggling with. We are struggling a little bit with slow frame rates, but
What's the? You can check if you middle mouse click on the particle sub, for example. How many particles or how many points are there?
52,900.
So something is wrong with the setting then.
The setting
What did I have? 0.2.
0.1.
So if I create 88,200 particles with a life expectancy of 0.2, I end up with a total of 17,000 particles.
Oh yeah, I have some life variance.
Everyone should maybe reset their particle system in case the numbers are changed in the wrong order.
Select the particles on the parameters, the state page, the reset button. So reset. And the other thing to check is if you have 1,470 points in your circle. Okay. Yeah, so the life variance might wreak havoc on your systems.
Okay,
If you turn life variance on the
44
particle page to 0, you're most likely to get steady results. And the other thing, how you can decrease, like one thing I did here, just to get this more extreme effect, I didn't change the thing that I really drove up is this multiply that we included earlier to scale up the normals. So if you go to this math 1, the first math we put in, and just crank up the multiply, your effect's gonna, like these particles, because these particles are actually rendered as lines. You can basically create this effect here just by multiplying the normals. What's happening is that the particle system is set to, if you look on the state page of the particle sub, the particles are rendering as lines, and the line length depends on velocity. So that's what you get. You get long lines and not single particles. If you would render this as point sprites, so it's points, as single points, then would look like this. As lines, it looks like this. So even with little particles, you can still create this effect fairly similarly. It's pretty late. The only thing that we'll add in now and skip the rest is
Save.
oh right, save.
Is to auto-save and Final Cut.
There's color in here,
No, where?
and this color is created by something that's called an RGB delay. That's a very simple but effective effect, I guess. So we'll explore how to build an RGB delay. Well, so the idea would be, okay, so you take, the idea of a delay is that you need more than one frame, because otherwise you don't have anything to look back to, right? Like in a delay, I look back for 0.1 a frame from 0.1 seconds ago or something like that. And so we need something to store frames. And we can do this by right-clicking on the transform and selecting the cache top. The cache top caches the amount of frames you tell it to put into cache. One obvious sign that this cache is actually like saving data is when you compare the GPU memory taken up by this transform, which is 3.52 megabytes, And this is just one node after, but it takes 116 megabytes. This is because it's saving actually the last 32 frames into one node. And it's got an output index as well. So you have access by changing the output index, like just playing around with the parameter. You're basically scrubbing in the history. But we want to do this with RGB separately. Now, we could copy this cache 3 times and have 3 different buckets for RGB. Luckily, apparently, lots of people need this. So there's a cache select node. So double-click onto the network and select a cache select top, which is a darker colored node, so it's a generator, doesn't need an input.
Is it top? No.
Top. We are totally in pixel space, so pixels is always texture operators. Cache select. So the cache select, what it basically, it needs a reference, it needs a cache top. So we'll take the cache 1 that we created, the cache top called cache 1, drag it onto the cache select top, and all that does, it fills the parameter, right? Like we have tried that a couple of times. Now the pretty nice thing about the cache select is that it acts like a select. So if you middle mouse click onto this, you see that it doesn't need any GPU mem. So it's pretty much a free. It's very light as well, cooking time. It's a free node. So I've got, but I still have the cache index, so I can scrub back here. Now
so it recalls what happened before then, or what?
Yeah, exactly. If I have the
Okay.
cache, if I set my cache index to a negative number, it gets stuff from earlier on. So I need this for RGB. So this is my cache select for red. Control copy, Control V, I've got it for green, I've got it for blue. Right, we don't have any color, like we are
Okay.
in black and white anyway,
Okay.
but let's offset cache index of the second one to -6. So I select the cache select 2, and then the parameters change the cache index to -6. So now I have to bring those back together. And every image has 4 channels, red, green, blue, alpha. Now, there must be some way in Touch to merge them back together. And one of the easy ways, it's called a reorder top. So I right-click on the output of the cache select top, look for the reorder, put it down. And again, this is total recipe, like just remember, and it will be helpful. The reorder top is extremely helpful for a lot of different reasons. So the reorder top takes 4 inputs, and if I look at the parameters, what it does is I can choose my output, like the red output channel should be my input 1, the red channel. But these are menus, so I can choose where my output red channel comes from input 1, from input 2, from input 3 or 4. And I can also choose which channel it should be. So I can swap channels in here, like color channels. I can make the green one the red one. I can make the blue one the green one or the alpha. But I can also mix different inputs. So by saying output green should be my input 2, green. And if I connect the cache select 3 to the third input, I can say output blue should be input 3, blue. Sorry? Cache select. Now when you play around with the output indexes, then you created basically an RGB delay with this network, with this setup.
Yeah.
The other thing everyone needs to do is to change the display flag. Maybe you should put a null at the end of your chain so that every time we add something,
That's a good
so
idea.
The display flag you're probably looking at is the transform from way earlier, and you don't see your last node. So,
And null is always a good idea. Yeah.
but then I don't think you have, right? So you can just play with it.
Yeah.
If you if you go across this network, you can, like for me, who came or who still comes from a non-3D background, and I'm
No big deal, yeah.
these networks teach me actually a lot about how things work internally, like how they give me visual feedback over what's happening. I can understand personally. I understand a circle more looking at the channels, like that describes positional data, and how the multiplying of a waveform with these channels, like what that looks like. What happens when you take a sine and you multiply it with an audio waveform? Well, you get a visual representation of that here, and you kind of, you learn what's happening. Similar with these effect things. By seeing the node layout, you see actually how an RGBA delay or an RGB delay in this instance, how that works. Like what is an RGB delay that's usually a name with 3 channels or with 3 parameters attached? How does it actually work? Well, you just build it. I find it very helpful to look at how do things work.
Yeah.
If you save this now, you are in a place where maybe I'll go over this something that we didn't cover here. Just quickly, we skipped over one part. The one thing that I wanted to do is that I have the left and the right channel on the left and the right side, which is not the case in what we just built. And I also wanted them symmetrical, so that the left channel starts from the bottom and the right channel starts from the bottom as well. So what you can do with channels is, for example, you can reverse their interval, which can be done with a stretch chop. There's a reverse interval. If you open up the AudioVis05 file,
Okay.
then you will see this little thing here where there's a stretch chop, which reverses the interval.
Pause, stop the timeline and show us what it does.
Right, so I'm just going to put down a pattern here, and the stretch chop on it. So the reverse interval is literally just doing this. It's not a good example.
No, do it on the, just toggle the audio waveform there.
Oh, here it's good
Show
too.
that.
Yeah, that's better. So 0, like time 0 becomes time 1, and time 1 becomes time 0, if you look at what it does. And this way, you get, if you look at this, you get a more symmetrical, you basically get a symmetrical layout here. Instead of what we did, we bunched channel 2 onto channel 1, so it's going to be still symmetric, but it's mirror symmetric, I think it's called.